For this next tutorial, I want to talk about conflict and specificity. So I've changed my HTML document just a little bit so that everything is in a p tag, or in a p element, I guess you could call it. This is only a test, a special test, classed special, a very special test, also classed special, and not so special. If I save that and look at it in my browser, then this is what it looks like. But that's because I deleted all my styles. So the reason I want to talk about conflict is because sometimes CSS rules are in conflict with each other. So what would happen, for example, if I said all P elements, I want to have a color of green. Okay, let's save that and look at it. Okay, every single P element has a color of green. Even though these ones are classed special, everything is green. But what happens if somewhere down in my CSS document I type P tags should really be colored white? Okay, now we've got a conflict. There's two rules that contradict each other. What will happen? Well, let's save it and look at it in a browser, refresh it. Okay, how did the browser decide to use white instead of green? Well, the rule is that if the selectors are the same, then the rule that comes last wins. If selectors are the same, the rule that comes last wins. Sometimes, however, rules aren't exactly the same. For example, what if I said p.special color green and p color white? There is a conflict here because with this rule I said make all elements with the p tag white. That comes last. But here I said make all elements that are classed special green. So will green win or will white win? Let's save it and see. Okay, so all elements are white except now the special classed elements are green. So why is that? Well, here's how you determine what wins when tags are similar. I'll just write it in here. First, you count the ID selectors, and you call that A. So if there were several ID selectors, let me just write an example. So if we have a div that is ID'd nav, and inside of that there are paragraphs, or there's a paragraph that is ID'd top, and inside that there is an M that is classed special. Then in this case, when I counted how many IDs and call it A, then I would say, well, there's one ID, two IDs. So I'd say there are two IDs. Okay? So that's the first thing you do. Number one, count the IDs. Number two, count the classes. In this example up here, there's one class. So, and you call that B. And in this case, there's one of them. Finally, you count the HTML tags, and you call it C. And in this case, here's 1, here's 2, and here's 3 HTML tags. Okay, so this particular selector would have a specificity of 213. This selector would have a specificity of 001. This would have a specificity of 011. So if we put all those together, let's see, 011 and 001, this one wins. This has the most specificity, so this rule will win out over these rules. Let me make a metaphor of that example and see if this makes any sense to you. Let's say that we're playing chess, and we've got a chessboard. It's everywhere. There's lots of red squares and black squares, and they do give us some structure, but the truth is that the chessboard itself in a game isn't very powerful. So the chessboard is like an HTML tag. It's there, but it has the least power when determining who wins in a conflict. The pawn, on the other hand, has more power. It's like a class. Truth is, though, that there are several pawns in a chess game, lots and lots of pawns. If I really want a lot of power, then what I need is a queen. There's only one queen on my side, and she's got more power than any given pawn, and more power than definitely more power than the chessboard. So the chessboard is like HTML selector, pawn is like a class selector, and the queen is like an ID selector. And that's how you determine specificity.